UN 영어뉴스 How X-planes may solve the sonic boom problem. Rocket-powered and shrouded in secrecy, X-planes helped pave the way for the US space program. Now they have another mission, taking the boom out of supersonic travel. In 1947, the first crew onlookers at Muroc Army Airfield, California, had that the sound barrier had been broken was a thunder-like sound or boom burst. It was the ninth powered flight of the experimental Bell X-1 aircraft, and on board, the pilot wrestled the controls as the aircraft's stability fluctuated as its speed increased. The legend of America's X-planes was born in the mid-1940s and flourished till the 1960s, when rocket planes flew to the edge of space. Flights by cutting-edge aircraft like the X-1 and X-50 paved the way for the eventual triumphs of the Apollo program and Neil Armstrong's first steps on the moon. The fastest of the X-planes would take their human pilots to more than 6 times the speed of sound. Now in 2023, the latest X-plane, the X-55-59 Quiet Supersonic Technology QSST aircraft, is aiming to repeat a feat achieved by the first X-plane, break the sound barrier again. Only this time, if all goes to plan, nobody on the ground will notice. In 1973, the US government banned commercial supersonic flights over land in the United States. With that ban, and others like it, went the business case for aircraft like Concorde. That might be about to change if years of research into how to create a quiet sonic boom come to fruition. NASA and the secretive skunk works of aircraft manufacturer Lockheed are trying to build an aircraft that creates it. Despite the advances in computer modeling and wind tunnel technology, it is still too much of a risk to build a quiet supersonic passenger aircraft without real-world evidence that the technology will work. I think the X-59 could be significant, says Christopher Combs, University of Texas at San Antonio. You are demonstrating for the first time with a real-world vehicle that you can make quiet sonic booms, and that can open the door for commercial industry to come in and start building aircraft like this. The Bell X-1 was the first X-plane to achieve supersonic flight. The X-1 looked like an aircraft designed to smash the sound barrier. It was a bullet shape with 2 straight wings. When it was designed, American aircraft designers hadn't fully understood the advantages of swept wings, such as reduced drag and a rocket engine. The fight-like X-59 is a rather more elegant and cost-effective answer to a challenging problem. The aircraft reuses parts from other planes, including the landing gear from an F-16 fighter, the canopy and ejection seat from a much older T-38 supersonic training jet, and some of the engine system used in the U-2 spy plane. Everything about the X-59 is designed to create a quiet sonic boom at the test point of Mach 1.4 at 55,000 feet, which is in the range a commercial aircraft is likely to fly. It will do this by minimizing the number of shock waves coming off the aircraft and spreading them more widely across the airframe to prevent them building up into a loud boom. The long nose of the plane, which at 38 feet is a third of the aircraft's entire length, is designed to separate the shock waves coming off the nose from those produced from the wing. The engines are above the wing rather than below it like those on Concorde, so shock waves don't travel towards the ground. The underneath of the plane is also unusually smooth for an aircraft. This is intended to minimize the number of shock waves it produces. The new X-plane will also be piloted by a human rather than a computer to help build trust with the communities it is flying over. The borrowed canopy, together with the X-59's long nose, means that the pilot won't have any forward vision. Instead, the X-plane has a digital external vision system, XVS. This uses a high-definition camera on its nose and another underneath to create a display for the pilot, which is the equivalent to a forward-facing window. We always kind of joke that the X1 broke the sound barrier, and now we are trying to fix it, says Catherine Baum, the project manager of Low Boom Flight Demonstrator, LBFD. Its sonic boom won't be loud enough for people to notice. It will be like distant thunder or your neighbor's car door closing that merges into everyday life. If we get the feedback that says this is the case from the communities it is flying over, we can ask them, the FAA, to change their standards, says Baum. If this happens, the X-59 will help open new markets for companies like Boom, Lockheed, or Gulfstream, who wouldn't otherwise make the significant investment themselves. People's sonic boom surprise caught on camera. Watch people's surprise as they hear a sonic boom from a Typhoon jet fighter over England in January 2021. However, for new era of supersonic passenger aircraft to be financially viable, they will need to be able to fly at supersonic speeds from airports in North America to Europe, for instance. So it's not just American standards we are seeking to change, it's global standards, Baum adds. For some, building an X-plane that produces a quiet boom is a long way from the glory days of breaking the sound barrier. It suggests that aviation is a mature technology that has run out of big new ideas. Others disagree. Integrating new ideas or new technologies is part and parcel of what the X-59 is all about, says Christian Gelger, chief historian at NASA's Armstrong Flight Research Center. As is the collection of real-world data, the engineers who are working on the X-59 want the data for the same reason as those who worked on the X-1, says Gelger. They are trying to find out if they can predict what an airplane will be like without having built it. No one had built anything like this before. Before the X-planes, scientists working for the National Advisory Committee for Aeronautics, NACA, the precursor of NASA, carried out their research in wind tunnels and with modified production aircraft, building a worldwide reputation for quality. Then, in the 1930s, it all changed. Aerodynamicist John Stack sketched out his idea for a purpose-built, full-scale research aircraft capable of reaching Mach 1, the speed of sound. 10 years later, Stack and a small group of engineers worked to turn this idea into a design for an actual high-speed test vehicle. The X-15 still holds the record for the fastest crewed aircraft in history, despite first flying more than 60 years ago. What was an off-the-books project grew in importance as rumors of German jet and rocket experiments began to grow. The USAAF, United States Army Air Force, heard about the project and they wanted one major change. The plane had to be powered by a rocket engine. Rocket-powered planes may sound ridiculous to us, but they were ideal to punch through the sound barrier because they had much higher acceleration and speeds than the same-sized jet aircraft. Supersonic flight today is built on what the X-1 taught engineers about supersonic airflow, the performance of materials at high speeds, and the most effective forms of propulsion, as well the data it provided on how supersonic flight affected human physiology. Stable flight in a subsonic regime had been happening since the Wright brothers, and suddenly you've got an aircraft that you've designed to push past these speeds, says Combs. That really sets the X-1 apart as one of the most impactful aircraft ever built. That's quite a landmark. That really sets a high bar for the rest of the X-planes. The golden age of the X-planes reached its peak at the end of the 1950s with the first flight of the North American X-15 in 1959. The X-15 was a big project. It dominated everything, and it did extraordinary things, says Gelger. It was a hypersonic demonstrator and still holds the record for the fastest crewed hypersonic flight at Mach 6.7, 5,100 miles per hour, / 8,160 km per hour between 1959 and 1968. The X-15 showed that you can go into space and come back and not require a capsule with a parachute. It flew 8 out of its 12 pilots to the edge of space and back, earning them astronauts' wings. Yet behind the glamour of the space race, the X-15 was essentially a flying laboratory. Around 765 research papers were produced investigating elements such as the biomedical effects of high-G flight and weightlessness, stability and control problems in flight and re-entry, the performance of aircraft structures at very high temperatures, and the accuracy of wind tunnels. The X-59, currently being built by Lockheed, features an extremely long nose to help dissipate shock waves at high speed. A ton of research came out of the X-15, but one of the things that is really overlooked is what it taught us about human factors, says Amy Shearer Tater, author of Breaking the Chains of Gravity, the story of spaceflight before NASA. We learned a lot about how to train pilots flying unconventional vehicles and to teach pilots how to deal with going far beyond what their normal was. A great deal of this research is still relevant today, particularly when it comes to hypersonic flight. There were definitely lessons learned from that program that we still talk about, such as how to maneuver at hypersonic speed, says Combs, whose own laboratory has a hypersonic wind tunnel. The X-15 program was cancelled in December 1968 after 199 flights. A new generation of X-planes followed, rather than piloted rocket planes designed to go higher and faster. The new X-planes were often uncrewed and designed to solve specific and unglamorous technical problems, and they have singularly failed to grab the public's attention. The X-43 was the first X-plane to use a scramjet, which ignites fuel while supersonic air passes through the engine. Rocket planes like the X-1 and X-15 was simply a hard act to follow. You had this handful of pilots who are flying to the fringes of space, and they were at the forefront of this new era, says Tate. There was a sexiness about that which appealed to people as well. It wasn't just the incredible technology, it was the future. Nevertheless, there have been many explains over the past 30 years, and records are still being set. BAM worked on a good number of them. The Lockheed Martin X-33 Venture Star was a demonstrator of the NASA Lockheed Martin project to build a successor to the Space Shuttle. It was cancelled in 2001 before any test flights could be carried out owing to the failure of the fuel tank during testing, although construction was 85% complete. BAM also worked on the X-43 scramjet-powered drone, whose sleek lines could have been designed by a Hollywood director. In March 2004, an X-43 set the record for the first time. A scramjet-powered vehicle had flown under its own power. A scramjet is a type of air-breathing jet engine in which combustion takes place in the supersonic airflow through the engine. 8 months later, an X-43 entered the record books when it achieved the speed of Mach 9.6 over 7,000 miles per hour per kilometer, and became the fastest air-breathing aircraft in history. That was a great project to work on, says BAM, who was deputy chief engineer on the record-breaking flight. Now, rather than going faster, the X-59 is aiming to be quieter, but it is only the start of their journey to quiet boom supersonic flight. The X-59 is kind of fighter jet scale, says Combs. The next question is, can you build a bigger one that's the size of a 737